You see averages everywhere, right? We use them to make sense of everything from our sports teams to the national economy. But what if I told you that this simple, everyday statistic can actually tell a profoundly misleading story? Today, we're going to put on our detective hats to uncover how averages lie, and more importantly, how you can spot the deception. And our first clue is surprisingly sweet.
Okay, get this. It's a fact. If you look at the data, there is a clear, statistically significant connection. The more chocolate a country eats per person, the more Nobel Prizes it wins. So, what's the deal? Is the secret to genius really just eating more chocolate? Let's find out.
All right, before you rush out and buy a truckload of candy bars, let's slow down and actually examine the evidence here. Is this connection as solid as it seems?
And I mean, you look at the raw data, and the trend looks rock solid. Switzerland is at the top for both chocolate and Nobel winners, while countries with low consumption are way behind. On the surface, it really does look like an open and shut case. But this is exactly where that first lie of averages starts to creep in.
Whoa, not so fast. This is our first major clue, and it's a classic statistical trap called the ecological fallacy. We're looking at country-level averages, but we're jumping to a conclusion about individuals. See, the country's high chocolate consumption is just an average of everybody. It tells us literally nothing about the Nobel winners themselves. For all we know, they could hate chocolate. That's the crucial flaw.
Okay, so the chocolate thing is kind of a fun brain teaser, but this kind of statistical mistake can have, well, life or death consequences. Let's shift gears to a real-world medical case to see how this exact same faulty logic plays out when the stakes are so much higher. Imagine you have kidney stones, and your doctor gives you two treatment options. You look at the overall success rates from a huge study, and the choice seems like a no-brainer, right? The less invasive procedure has a much higher success rate.
I mean, the numbers are right there. Any rational person would pick the treatment with a nearly 83% success rate. But what if I told you the whole picture is lying to you?
But just look at what happens when we break the data down by one tiny crucial detail, the size of the kidney stone. Whoa. The entire story flips on its head. Suddenly, open surgery, the one that looked worse overall, is actually more successful for both small stones and large stones. How on earth is that possible? Well, this totally mind-bending twist is a real thing. It's called Simpson's paradox. The overall average was hiding a key variable, stone size. Turns out doctors were, logically using the easier, less invasive procedure on the smaller, easier to treat stones. So of course its overall success rate looked better. When you mash all that data together, you completely lose the most important part of the story.
So where did this ghost in the data come from? How did we all become so obsessed with a single number that can be so dangerously misleading? Well, to figure that out, we've got to take a trip back in time.
It feels so normal to us now, but for a long time, the whole idea of taking an average was, well, it was controversial. Scientists actually thought one single perfect measurement was way better than a messy average of a bunch of different ones. It wasn't until the 18th and 19th centuries that the average really started to catch on, and it all led to this radical new idea, the average man.
And this is the guy who changed everything. His name was Adolphe Quetelet, a Belgian statistician. He took the idea of an average, which back then was mainly used in astronomy to pinpoint a star's true location from a bunch of wobbly observations, and he did something radical. He applied it to people. And that's where things got complicated.
So, he's looking at the chest measurements of thousands of Scottish soldiers, and he has this wild thought. He started to think the average wasn't just a summary. No, he believed the average was the ideal, the perfect, true soldier that nature was trying to make. And every actual person's chest size? Peef. In his mind, that was just a mistake, an error, an imperfection.
And right there, that's the giant problem. Quetelet gave us this incredibly powerful tool, but he also baked a huge flaw into how we think, this idea of an average person who's perfectly average in every single way. The thing is, that person doesn't exist, not anywhere.
And this brings us right to the core mistake, which has a fancy name, the ergodic switch. It's super simple, really. It's when you take something that's true for a group as a whole, and then you just assume it must be true for every single individual in that group. It's the exact same mistake we made with the chocolate and the kidney stones.
Here's a really easy way to get your head around it. Imagine you've captured some enemy cannons. One spy tells you they're 8-inch cannons. Another spy says, no, they're 9-inch. So what do? Order the average?
8.5-inch cannonballs, right? Wrong. Now you have a giant pile of cannonballs that fit absolutely nothing. The average is a total fiction that doesn't match reality.
But wait, the story doesn't even stop there. Even when using an average makes sense, the kind of average you choose can tell two completely different stories. This is the tale of two averages, the mean versus the median.
So the mean, that's the one we all learned in school. The traditional average. You just add everything up and divide. But it's really sensitive to outliers. A few crazy high or low numbers can pull it all over the place. The median, on the other hand, is just the middle value. You line everything up and pick the one smack dab in the middle. It's tough. It doesn't get pushed around.
Let's see this in action. It makes it super clear. Okay, picture a small company with 5 employees. We calculate the mean, the traditional average, of their salaries, and we get $4,000. But if we find the median, the salary of the person literally in the middle, it's only $3,000. See what happened? That one person making a lot more money pulled the whole mean upwards, making it look like the average salary is higher than what most people there actually earn. So which number tells the real story? Well, it all depends on what you want to know.
Okay, so now that we know all this, how do we become better data detectives in our own lives? How do we stop falling for these statistical traps? All right, here it is, your official detective's toolkit. The next time someone throws an average at you, just pause and ask these questions. First, could there be hidden subgroups in here, like with the kidney stones? Second, does this group data really apply to an individual? Third, could a few outliers be skewing the whole picture? And finally, are we talking about the mean or the median? Just asking these 4 questions will make you so much smarter about the data you see every day.
So here's the bottom line. Averages are powerful, for sure, but they are also abstractions, and they can hide way more than they reveal. The average person, the average patient, the average customer, they're all statistical ghosts. So from now on, whenever you see an average, remember to ask the single most important question you can. Who or what is this data really describing?